Hey, welcome to The Explainer. Today we're talking about something that sounds like it's pulled straight from a sci-fi movie, a technology that could let an aircraft fly in complete, total silence.
Yep, you heard that right. Just think about it for a second. A plane with absolutely no spinning propellers, no roaring jet turbines, nothing that moves. I mean, how on earth could that even fly?
Well, it's called an ionocraft, and it almost looks like a high-tech kite, doesn't it? So delicate. But believe it or not, that simple frame is the key to this whole new kind of propulsion that uses nothing but pure electricity. Okay, so how does a frame like that actually get off the ground? Well, it all comes down to a propulsion system that is totally different from anything you've probably ever seen. So the fancy term for this is a solid-state propulsion system. And really, all that means is that the parts creating the push, they don't move at all. Instead of, violently shoving air backwards with a spinning blade, it uses electricity to create this gentle, silent wind. And that right there, that's the heart of this whole thing. It's called ionic wind. Now, the physics might sound a little intimidating, but trust me, the basic idea is actually super cool and elegant. Let's just walk through it. All right, so let's break this down. First, you take a really, really thin wire and you pump a ton of high voltage into it. What happens next is that powerful charge actually rips electrons off the air molecules floating around it. That creates these positive ions. Now, because likes repel, those positive ions get shot away from that positive wire, and they accelerate towards something called a collector. And as they're zipping along, they smash into all the other neutral air molecules, creating this kind of chain reaction that pushes a whole bunch of air backward. And boom! All those tiny collisions add up to create real thrust, a steady, silent wind. And that whole process, that's the key to the science behind it all. It's called Electrohydrodynamics, or EHD for short. Sounds super complicated, right? But it's not. Electro is for the electric field, and hydrodynamics is just a fancy way of talking about moving a fluid. In this case, the fluid is just the air around us. What's amazing is how simple the actual device is. You've got that super thin emitter wire we talked about. Sometimes they call it a corona wire. Then you've got a collector, which can literally just be a piece of foil. In between those two is the air gap. That's where all the action happens. And a super lightweight frame just holds it all in place. That's it. That's the whole machine. So you might be thinking this is some cutting-edge 21st century tech, right? Well, what's really wild is that this idea has been around for a very, very long time. I mean, just look at this timeline. The basic idea was first written about way back in 1709. Can you believe that? Then, it took until the 1950s and 60s for people like Major Disiversky to even fly tethered models. It really wasn't until our lifetime that the technology finally caught up and made a self-powered flight a real possibility. And, of course, the history has these amazing little side stories. There was this American inventor, Thomas Townsend Brown, who was absolutely convinced he discovered an anti-gravity effect. He even gave it a name, the Biefeld-Brown effect. But it turns out he was wrong. Other scientists figured out it wasn't anti-gravity at all, it was just EHD. The big giveaway? The craft didn't work in a vacuum, which it would have to if it were actually defying gravity. So, that begs the question, right? If the principle was known for over 300 years, why did it take so long to build a plane that could actually fly on its own? Well, the problem was really simple: power. The power supplies you needed for the high voltage were just too big and heavy. The little ionic wind they created just wasn't strong enough to lift them. But then, everything started to change. Power supplies got smaller, they got lighter, they got way more efficient, and that's where the story really, pardon the pun, takes off. So in the modern era, there are really two huge breakthroughs you need to know about. Back in 2006, an inventor named Ethan Krauss built this vertical takeoff craft, and it was the very first one to actually lift its own power supply off the ground. That was the proof of concept we needed. Then, in 2018, the team at MIT took the next giant leap. They built a plane that looked more like a traditional airplane, and after a little launch assist, it flew under its own power for 60 meters. This was huge because it proved the concept could work for actual airplanes, not just little vertical lifters. So, these incredible successes have really opened up the big question: what's the future for this kind of silent flight? I mean, could it ever really replace the noisy jet engines we're all so used to today? Well, the potential benefits are just massive. You're talking about almost silent operation, way less maintenance because there are no moving parts, and, of course, zero carbon emissions. But maybe the biggest game changer of all is its potential for incredible efficiency. Okay, I want you to remember this number, 111. 110. That's the potential thrust efficiency of one of these ionic thrusters, and it's measured in newtons of thrust per kilowatt of power. Now, just to put that number in perspective, let's compare. A modern super efficient jet engine gets you about 2 newtons of thrust for every kilowatt of power. The ionic thruster? Potentially 110. That is more than 50 times more efficient. It's just a mind-blowing difference. Okay, but let's bring it back down to Earth for a second. We have to be realistic here. This tech only works if there's an atmosphere, so it's useless for space travel. And for now, the amount of thrust it creates is, well, it's tiny. People describe it as a gentle breeze, so it's nowhere near powerful enough to get a passenger jet off the ground. At least, not yet. And that leaves us with the big final question. With that incredible potential for efficiency and its silent operation, could this really be the future? I mean, can you imagine a sky full of silent drones? Or maybe even one day, larger planes just gliding through the air, pushed along by nothing more than an invisible electric wind? It's an amazing thought, and only time will tell if it becomes reality.